Okay, so the first thing we're going to do is we're going to look at the special 7. So special 7. And as I look here, I can see that yes, H2 and F2 are the special 7, but they're already accounted for as 2, so there's nothing I need to worry about. So I'm just going to say not applicable. Okay, NA, nothing to worry about there. My next step is to balance the metals. Okay, and as I look, as a reminder, here's my periodic table. Remember when I'm looking at order of stuff and what to do here. As far as metal versus non-metal, remember the dividing line. Everything to the left is metals. Everything to the right is non-metals. So when I'm looking for metals, I'm looking for everything, but I'm not looking for H, hydrogen, or oxygens because they have their own steps later. So I worry about that when I get there. I'm not going to worry about that this second. Okay, so I balance the metals. If I look here, H has its own step. I don't worry about it. F is not a metal. Again, we talked about H, we talked about F. So there is no metals. So again, nothing to do, not applicable. Okay, my next step is to balance the nonmetals. And as I look at this, the only nonmetal I see is fluorine. Okay, I have 1 fluorine on this side, I have 2 on this side, so the easy balance, remember we add to the side that has the least amount. There's 2 fluorines here, 1 fluorine right there, so I'm going to add to this side. If I put a 2 there, that gives me a simple solution. 2 fluorines, and then I have 2 fluorines over there, so that balances fluorine. So I'm going to write here 2 on HF, and the effect that has is that it balances fluorine. Okay, I balance fluorine. Now, I do know that hydrogen was adjusted because this 2 applies to everything here, so hydrogen was obviously adjusted, but since hydrogen has a step later on, I'll worry about that later. I don't have to worry about it just this moment. The only time you worry about something else is if your current step messes up a step that you've already passed, like a prior step. So if you say something's balanced in a prior step and your current step messes it up, you got to go back and fix it. And you'll see that example later on. Right now, here's what I'm telling you. When I put this 2 on there, I do balance fluorine because that's what I'm focused on. 2 fluorine, 2 fluorine. And I do know that the hydrogen gets adjusted too, but because hydrogen has a step later on, I'll worry about it when I get there. Okay, so this is when I get there. Now it's balance hydrogen time. So there's the hydrogen. And I see here that there's 2 hydrogen on this side, and I see that there's 2 hydrogen on already balanced. It just already worked on its own. So I'm just going to say already balanced. So really there's nothing I need to do on that one. Okay? So then I'm going to go to this one. The next thing I balance is balance oxygen, or the next thing on my list is to balance oxygen. If you guys look, there's obviously no oxygen, so it's not applicable. There's nothing I have to do about it. Okay, it doesn't apply here since it doesn't exist in this problem. My next thing is that step 6, 7. Remember, that's just checking your work basically. Okay, here's what step 6, 7 is altogether. The first thing is add ones to blank coefficients. Add ones to blank coefficients. Reduce if possible. And we're going to check our work. So those are the steps 6, 7. Okay, I'm going to rewrite our final, what we ended up with up here. So that's going to be this. We have 2 HF H2 F2. That's what we ended with. Okay, so here's what step 6, 7 does. Step 6, 7 says add ones to blank coefficients. Okay, These are the blank coefficients right here. There's nothing in there. Yes, it's assumed to be 1 since it's blank, but because this section is having to do with balancing, I need you to prove to me you know it's 1. So I need you to fill it in. I need you to write those 1s in. In the future, once it's not amateur hour anymore and you're good at this stuff, you don't have to fill in the 1s anymore. But right now, I need to know, did you leave them blank because you knew it's a 1? Or did you leave them blank because you're not out of time? Did you leave it blank because you didn't know? Or do you see how I have to guess? But if you put a 1 in there, you're telling me you know 100% it's a 1. So here's what I got to tell you guys. If you forget to put 1s in the blank places, it may be balanced correctly, but you're going to lose points because you didn't follow the directions. And I need you to add those 1s. So right here, I'm gonna add that so I know that that's what I did. Add 1 on H2 and F2. So I added a 1 to both of those. Okay. So again, 1 on H2 and F2, that's what I did here. Reduce if possible. Look at my coefficients, 2, 1, and 1. There's nothing I can divide out. I can't reduce these numbers by dividing something that's in common to all of them, so it's already reduced, so nothing I need to do there. Okay, now I check my work. Remember, checking your work is making sure that both sides have the same amount of the elements. Okay, and here's where this is just bookwork. List all the different elements that you see. I see hydrogen and fluorine. Those are the 2 different elements. Okay, and now I just compare. This side has 2 hydrogen, so I just 2 hydrogen there. This side has my 2 hydrogen right there. 2 times that 1 makes it 2. This side right here, fluorine. 1 fluorine here times that 2 makes this 2. 2 fluorines here times the 1 in front of it makes it 2, and it's balanced. So I know that that's a great final answer. Okay, so that'll get you full credit. Now, as far as your notes when you're at home and you're looking at this, I'm going to make a video of this so you guys can see it later, but if you're just no access to video at the moment and you're looking at these notes, here's what I recommend. Start the problem over. Rewrite it without the coefficients. Don't put the 2 there. Don't put the 1s there. Just start blank. Start brand new. And follow what it says, like this. See if I cover that right there. Now I have what it looks like when it started with. And if you're at home, you're just going to say, okay, special 7 doesn't exist or doesn't apply, so no change. That's why it looks the same. Balance metals, no change, so nothing happens. Balance the nonmetals, 2 on HF, so that balances fluorine. And then, so now you would write a 2 at home, and then you just keep going through the story and just follow what it tells you, and you'll start seeing those patterns. Okay? So again, this is kind of so you can see step by step what happened to get you to the end result. Okay? Okay, so here's example 2. So again, just go through the process. Special 7. Doesn't apply. This is a special 7, but it already has a 2, so it's already adjusted or done already for you. You don't have to worry about it. So not applicable. Okay, the special 7 happens more often when you are reading the English sentence and you're transferring it to this skeleton equation, but usually when we give you the skeleton, the special 7 tend to be done for you, but sometimes you still got to look, okay? You just want to make sure. Balance metals. Balance metals. Okay? So that's my next thing. I want to balance some metals. So the only metal here is going to be aluminum then that we're going to worry about. I'm not going to write nothing yet. So I focus on aluminum. 1 aluminum, 1 aluminum. It's already balanced. Okay, so I'm just going to write already. It's already balanced. There's nothing I need to do for that one. Okay, so then I go to nonmetals. Okay, and as in the chat box it already says, bromine is the nonmetal that I want to focus on. There's 2 bromines here and only 1 here. So my solution is to put a 2 there. Okay, so I'm going to write that 2 on AlBr. When I do that, I balance bromine. Okay, I balance bromine when I do that. So, because I put a 2 there, we affect aluminum as well, and then what ends up happening is we unbalance aluminum in the process. Okay, so in this step, one good thing happened and one bad thing happened. We balanced bromine, but ended up unbalancing aluminum. Now here's the deal. We have already said that aluminum was balanced in a prior step. So when that happens, when your current step messes up something that you've already fixed, now it's time to go back and fix that mistake. Okay, so if you guys notice here, so the next thing I'm going to work on is I'm going to look at aluminum. So there's a 2 here, 2 aluminums here, 1 aluminum here. So if I do that, now all of a sudden aluminum's rebalanced, and because this aluminum is by itself, nothing else is affected. So I'm going to write that down here. Okay, so the next thing I did is I'm going to put a 2 on Al, and that ends up rebalancing my aluminum. So that's where I'm at with that one. Okay, so again, on this step, make sure you understand, when I put a 2 on AlBr, it balanced bromine, 2 and 2. But it also affected the aluminum. So that's why I wrote it unbalanced aluminum, and then I fixed it. I put a 2, that 2 is this 2 right here. So now it's balanced, okay? And so that's why I wrote that, I balanced aluminum. So I went back to fix something that had already been balanced previously, okay? So that's how I take care of that one. The next thing is I'm going to balance hydrogen. Doesn't apply because there is no hydrogen. Balance oxygen. Doesn't apply because there is no oxygen. So now it's just basically up to step 6 and 7. Okay, I'm going to add 1s. I'm going to reduce. And I'm going to check my work. Okay, I rewrite my final what my reaction ended with. So 2 aluminums, and then Br2, and then 2 AlBr. Okay, so that's what it ended as. Add 1s, so I'm going to say 1 on Br2. So that's that right there. Reduce, 2, 1, 2 is reduced as it gets. There's nothing I can do, so now it's check work time. I have aluminum and I have bromine in this reaction. So I just got to compare both sides. 2 aluminums contributed here. This 1 aluminum times that 2 makes it 2. 1 aluminum here times the 2 in front makes that 2. There's 2 bromines here times the 1 in front makes that 2. There's 1 bromine here times the 2 in front makes that 2 bromines, so that's balanced. That's a great final answer. Anyone have any questions on that one? So balance the special 7, or look at the special 7. Doesn't apply here. Okay. Oxygen's already done, so I can skip it. Balance metals is next. The metal that we have is iron, I'm sorry. Iron here. There's iron, 1 iron here, 2 irons there. So my solve is to put a 2 there, so I balance iron. Okay, I'm only worried about iron at that step. So 2 on FeO, and that serves to balance iron. So that's what I do there. Next, balance nonmetals. Okay, there is none. Okay, so not applicable. There is no non-metals. Okay. The next thing, balance hydrogen. balance hydrogen, okay? No hydrogens, not applicable. The next step, balance oxygen. So now I'm going to work on oxygen. So this is the first time we see this. There's 2 oxygens here, okay, and there's 2 more here, but they're on the same side, so I can combine. Remember, the dividing line is the arrow. So I combine like terms. 2 oxygens here plus these 2 oxygens, that makes 4, and I have 3 oxygens on this side. So this has the least amount. So I'm going to add to this side, okay? I try to do the least disruptive and the lowest numbers as possible, so I'm just going to try a number 2 here. Okay, so I'm going to say 2 on Fe2O3. So 2 on Fe2O3. And the reason I did that is because, no, we're not balancing nothing yet. We're just trying. Okay, nothing's happened just yet. I put a 2 there in an effort to be on the way to balancing oxygen. So here's my 6 oxygens now. Now on this side has the least amount. There's 2 here and 2 there for 4. I have a couple options here. I could put a 2 here. If I put a 2 there, that gives me 4, plus those 2 gives me 6, and I do balance oxygen, but I still have an iron problem. Okay, so before I do that, I kind of think, can I solve it maybe all together here? Okay, so at this point, I say to myself, okay, let me make this a 3, and I realize quickly 3 doesn't help because that just gives me 3 irons, and there's already more on the other side, so that's no help. But 4 could help. So I cross that out, and I make a 4 there. Okay, so now I'm going to say 4 on FeO. Okay, and when I do that, since the Fe and the O are affected, it might be able to help me out to solve both of the problems I'm having now. So let's remember, the first thing we were focused on was oxygen. So I can see here these 4 oxygen plus those 2 oxygen. That's going to give me the match, that's 6 of them, to match these 6 here. So now I have balanced oxygen. Okay, so now I have to worry about iron because iron was balanced earlier, but I just disrupted all that. There's 4 irons here, and now I do have 4 irons there now, so it balanced on its own. It just happened to work out that way. So now I have iron balanced. So I can write that. Okay, so now I go to the last step, the 6, 7 step, since I've done everything I'm supposed to do up to that point. Remember, this is add ones. Let me scoot that up for you guys. Okay, add ones, reduce, and check work. Here's the last rendition of my balanced equation. It looked like that. Okay, so add ones to the blanks, so that's that one right there. So I'm going to say 1 on O2. So that takes care of that. 4, 1, 2 can't be reduced. I can't subtract anything else out of there. Or not, I'm sorry, not subtract, divide anything else out. There's nothing in common that I can divide out to make those smaller. And then the last thing is to check my work. I know I have iron and oxygen in this one. Okay? This 4 plus the 1 iron times the 4 in the front gives me 4. Okay? 2 irons here times the 2 in front gives me 4. 4, the 1 oxygen here times this 4 gives me 4. The 2 oxygens here times that 1 gives me 2. So I add that together, that gives me 6. And on this side, the 3 oxygens times that 2 gives me 6. So that's perfectly balanced. And that's a great final answer there. Okay? So again,